You know, every single time you click a mouse, type on a keyboard, or swipe on a screen, there's this silent, invisible masterpiece of engineering that's making it all possible. Today, we're going to pull back the curtain on that masterpiece, the operating system.
To really get a grip on just how important it is, let's start with a thought experiment. Imagine you have all the pieces, the processor, the memory, the screen, but no OS. What do you think happens when you turn it on?
You get chaos. Total, absolute chaos. I mean, picture it, a symphony of incredibly powerful components with no conductor, no sheet music, and no clue how to work together. It's just electronic noise.
So here's our game plan. We're going to see exactly how the OS brings order to that chaos. We'll start by defining our conductor, then see how it juggles programs in memory, acts as a librarian for all your data, protects the whole system, and finally, we'll take a little peek into the future.
Okay, so let's start with this idea. Think of the operating system as the ultimate manager. It's the conductor of the orchestra, right? The CEO of the company, the traffic cop at a crazy busy intersection. It doesn't actually do the tasks itself, but it's the one making sure everything else runs smoothly.
At its heart, this is the textbook definition. The OS is that fundamental piece of software that sits right in the middle, acting as the translator between you, your apps, and the actual physical computer hardware. It's the bridge that connects absolutely everything.
And wow, its job description is just massive. It's like this digital octopus with a tentacle in every single part of your system. It's deciding who gets to use the processor, it's handing out memory, it keeps track of every single file, talks to your keyboard and your printer, and it gives you the interface, whether that's a blinking cursor or the colorful world of icons and windows that you interact with every day.
So, let's tackle the first big puzzle. How in the world does your computer do it all at once? No, seriously, stop and think about your own computer right now. You might have a dozen tabs open, music playing, a word processor running. How is one single CPU core handling all of that without just collapsing?
Well, here's the first secret. The OS doesn't just see programs, it sees processes. And a process is basically a program that's actively up and running. The OS wraps each one up in its own little protective bubble, with its own memory and its own resources, keeping it totally separate and safe from all the others.
And here is the real magic trick, something called context switching. The OS is like an unbelievably fast magician. It gives the CPU to your web browser for a few milliseconds, then boom, it instantly saves its state and swaps in your music player. It does this thousands of times every single second, creating this flawless illusion that everything is running at the same time.
And this isn't random. The OS has a whole playbook of clever rules or scheduling algorithms to decide who gets the CPU next. But this is where things get really interesting. It's a constant balancing act. First come, first served is fair, but one really long task could hold up everything else. Round robin is also fair, giving everyone a tiny slice of time, but it might not be the most efficient. The algorithm the OS chooses is this crucial trade-off between being fair, being efficient, and making sure your computer feels responsive.
But you know, this incredible juggling act, it can go wrong. What happens when two programs each need something that the other one is holding on to? Well, they get stuck in this digital standoff, just waiting for each other forever. This disaster is called a deadlock. And the tricky part is that it only happens when you get this perfect storm of these four specific conditions all happening at the exact same time. So a huge part of the OS's job is to have smart strategies to either prevent these conditions from happening at all or to spot the deadlock and break the cycle before your entire system grinds to a halt. Okay, so besides managing who gets to think, the OS also has to manage where they think. And that brings us to maybe the most precious resource in your whole computer, memory.
This is a problem we have all faced. A new game comes out, it wants 16 gigabytes of RAM, but your laptop only has 8. How is that even possible? I mean, you'd think it would be like trying to pour a gallon of water into a tiny pint glass.
The answer is another incredible illusion, another piece of magic from the OS called virtual memory. Essentially, the OS tricks each and every program into thinking it has access to this vast private ocean of memory, way, way bigger than what's physically installed in your machine. And this analogy just nails it. The OS is the building manager. It gives every single application a key to its own virtual mansion. Now, the parts of the program you're using right now are kept in the super fast RAM apartment, while the rest is stored away in the slower hard drive storage unit.
The OS is constantly, seamlessly swapping pieces back and forth so you never even notice. It's brilliant. So, we've got our programs running, our memory is all sorted out, but where do we actually keep everything? Our documents, our photos, our games. Well, that's where the OS puts on its librarian hat. The files system is the OS's master catalog. It's the reason you can have two files with the exact same name, like report.docs, as long as they're in different folders. The system tracks their unique paths, just like a librarian knows the exact shelf for every single book. It also decides how to physically store that data, using systems that have evolved over time, from older ones to modern ones that add crucial features like security and data protection.
All right, so with all this valuable information running around in memory and stored on the disk, the next logical job for the OS is pretty obvious, right? It has to become the system's security guard.
Now, there's a really key distinction to make here. Protection is about the internal rules. Think of it this way. Protection is the lock on your bedroom door, preventing your roommate from going through your stuff. Security, on the other hand, is the alarm system on the whole house that keeps burglars out. The OS has to handle both, making sure programs don't mess with each other and that external threats are kept out.
So we've seen how the OS acts as a conductor, a juggler, an architect, a librarian, and a security guard. But the world of computing never, ever stands still. So what's next for our invisible conductor? Well, the future seems to be all about being specialized and distributed. Operating systems are evolving to manage not just one computer, but these massive networks out in the cloud. They're becoming hyper-efficient for our phones and mobile devices, and you've got these game-changing technologies like Docker, which packages apps into these neat little portable containers, and even unikernels, which are these ultra-specialized tiny OSs built for one single purpose. The fundamental problems are the same, but the solutions are constantly adapting.
Which leaves us with one final big thought to chew on. As computing becomes more and more ambient, woven into our cars, our homes, our lives, will the operating system we've just been talking about become even more critical to manage all that complexity? Or will it just do its job so perfectly that it becomes, for all intents and purposes, completely and utterly invisible?